Very good morning, students.
Good morning.
Yes, sir. Good morning, sir.
Good morning, all of you. Let us start the discussion without wasting any time. So, last class we have been seeing about reference electrode and all. That means whatever the electrode potentials we are going to define for a particular electrode, they were defined, they were valued with respect to the some reference value, with respect to some reference electrode. So, at anode, we can have H2 converting into H plus plus 2 electrons. At cathode, we have 2 H plus plus 2 electrons converting to H2. Under standard conditions, the electrode potential of hydrogen electrode is 0. That means stranded hydrogen electrode has a 0 electrode potential. We can use that SHE to calculate the standard electrode potential of any other electrode. Like for example, if I want to calculate E of Zn to Zn plus 2, I'll use SHE as a cathode and E of cell I'll measure using the device and I can actually calculate it. Right? This is the last point of our discussion. Primary reference electrode is stranded hydrogen electrode, SHE. Representation: platinum, H2 gas and H plus ions 1 molar when it is acting as anode. Anode means oxidation occurs, that means H2 gas from the 0 oxidation state is converting into H plus ions. Cathode means reduction occurs. H plus ion will take up the electron to form H2 gas. E naught of H2 gas to H plus ions is standard oxidation potential that was assumed to be 0. H2 is converting into 2H plus plus 2 electron when acts as cathode. 2H plus plus 2 electron converting to H2 when it is acting as cathode, like 2H plus plus 2 electron gives us H2. Cathode means reduction, so reduction happening. This is happening. Anode means H2 is converted into 2H plus plus 2 electron, and E naught of H plus to H2 or H2 to H plus, both are assigned to be 0. Both the values are assigned to be 0. So this is your standard hydrogen electrode. You have a platinum wire and a platinum electrode and 1 molar H plus, that is HCl solution, and now we are passing the H2 gas. The H2 gas, whatever has been passed, that gets absorbed on the platinum electrode, on the rod of platinum, and that H2 gas which got absorbed, and that is going to be develop an equilibrium with the H plus ions in the solution. That is going to develop an equilibrium with the H plus ions in the solution. 2H plus plus 2 electron gives rise to H2. This is how the equilibrium has been developed. And you can use SHE, standard hydrogen electrode, as anode or as cathode. Is that clear, students?
Yes, sir.
Yes, right. Very good.
Yes, sir.
For standard hydrogen electrode, potential is arbitrarily assumed to be 0 at all temperature. Standard oxidation potential is equals to negative of standard reduction potential, that is equal to 0 for SHE. But if you try to change the concentration of H plus ions, the standard hydrogen electrode will not have the 0 electrode potential. If I try to change the concentration of H plus ions in the hydrogen electrode, then it will not have 0 volt. To calculate standard potential of any other electrode, a cell is coupled with the standard hydrogen electrode and its potential is measured. That gives the value of electrode potential of that electrode. Understood this point or not? To calculate standard potential of any other electrode, a cell is coupled with SHE. Like we have coupled the zinc palladium ZnSO4 with a SHE, and we have find out the electrode potential which has been seen the reading. With respect to that reading, we have calculated the electrode potential of that particular Zn to Zn plus 2. So this is how the cell is happening. So we are trying to measure the electrode potential of Cu plus 2 to Cu. Cu plus 2 to Cu is undergoing reduction. That means it is taken as a cathodic half cell. So E of cell is equals to E naught of cell is equals to E naught of SHE is taken as anode. Anode means oxidation occurs. So H2 to H plus E naught of Cu plus 2 to Cu. What is this value E naught of H2 to H plus?
0.
That value is assigned to be 0. What is E naught of cell? How do you know E naught of cell?
Through voltmeter.
Okay, reading of voltmeter or reading of device which can measure the potential difference, and that reading itself is assigned to be E naught of Cu plus 2 to Cu. So calculation of electrode potential E for unknown electrode. So the H2 gas has been absorbed and electrons are actually traveling from anode to cathode. And whatever the reading we have seen, that is E naught of cell. That E naught of cell is nothing but 0.34, that is equal to 0 plus E naught of Cu plus 2 to Cu. So E naught of the standard reduction potential of copper is 0.34, but it is measured with respect to the reference standard hydrogen electrode. Using the SHE, using the standard hydrogen electrode, we have measured the standard reduction potential of copper, right? And we have some secondary reference electrodes also. Like instead of having SHE, we can also have other electrodes like silver chloride electrode, calomel electrode. Whatever the standard electrode you are using, that can be taken as anode, that can also be taken as cathode. That has to be the condition. So whenever silver chloride electrode is used as anode, Ag solid plus Cl minus is converting into AgCl solid plus electron. Anode means oxidation should occur. So 0 to plus 1, increasing the oxidation should happen. Cathode means reduction occurred, plus 1 to 0, decrease in the oxidation state has been seen. AgCl plus electron gives rise to AgZO plus Cl minus. Ag solid means Ag in the 0 state. Calomel electrode, Hg went from 0 to like Hg to Cl2. What is the oxidation state of Hg to Hg in HgCl2? Plus 1.
This one.
And here plus 1 to 0. So at anode oxidation occurred, at cathode reduction occurred. So Hg in the liquid state plus Cl minus converting into Hg to Cl2 solid plus electrons. So these are the other reference electrodes which are nothing but silver chloride electrode and calomel electrode. Other reference electrodes. Right? But generally in the electrochemical series, all the electrode potentials were valued with respect to the standard hydrogen electrode only. With respect to standard hydrogen electrode only, the electrode potential of all other species have been valued. This is your electrochemical series. Look at the series. Lithium is formed from Li plus ion. Li plus takes the electron to form Li solid. K plus takes the electron to form K solid. Ba plus 2 takes 2 electron to form barium solids. Like that, we have different SRP values. Look at the SRP values. SRP reduction potentials have been mentioned because based on the IUPAC system, we have to mention the standard reduction potentials. The reduction potentials have been arranged in the increasing order or decreasing order.
Increasing order.
Minus 0.35, minus 2.93, so to on up to plus 2.87. The SRP, okay, in the electrochemical series, arranged in increasing order of SRP, standard reduction potential. It is arranged in the increasing order of standard reduction potential. If you look at the species, like Li plus electron is forming Li, it is having SRP of electrode potential of minus 3.05. Can I say reverse value? Li converting into Li plus electron is how much?
Plus 3.0.
Plus 3.05. So lithium has a electrode potential is positive. Greater the electrode potential, greater the tendency for the reaction to occur. So lithium has a greater tendency to form Li plus ion. That means lithium has a greater tendency to undergo loss of electron. So lithium has a greater tendency to undergo oxidation. So lithium is going to be the strongest reducing agent or not? Yes or no? So
Yes, sir.
reducing agent, strongest reducing agent means highest standard oxidation potential, because reducing agent undergoes oxidation. Something which is undergoing oxidation, that can act as reducing agents. So lithium is undergoing oxidation at a greater density. So highest oxidation potential, standard oxidation potential means strongest reducing agent. So that is why the top elements like lithium, potassium, barium, calcium, they have the highest reducing tendency. They are strong reducing agents. And I can also say highest standard oxidation potential means lowest,
Standard reduction potential.
very good, lowest SRP. So strongest reducing agent will be having the lowest standard reduction potential. That is also the point which you need to understand. Right? And you look at the increase in the last one, like F2 plus 2 electron gives us 2F minus. So highest SRP standard reduction potential means, so great tendency to undergo greatest tendency to undergo reduction. Something which has a greater tendency to undergo reduction, it is nothing but a strongest oxidizing agent. Strongest oxidizing agent means highest standard reduction potential. Strongest oxidizing agent means lowest standard oxidation potential, or SOP. Right? From this electrochemical series, we can actually look at different factors like applications we can see. So look at the applications: oxidizing power and reducing power. Oxidizing power means what? Oxidizing power means I have to oxidize something else. I have to oxidize something else means like a particular chemical species has to oxidize something else means by itself it should undergo reduction. So I have a great tendency to oxidize something means I have a great tendency to undergo reduction. Something which has a great tendency to undergo reduction, its reduction potential is high. So oxidizing power is directly proportional to SRP. SRP and SOP are inversely proportional for the same electrode. So oxidizing power is directly proportional to tendency to undergo reduction. Great, like oxidizing power is the ability to oxidize something else. That means the ability to undergo reduction within itself. That means the highest reduction potential. Greatest is the standard reduction potential. Smallest is the respective oxidation potential. Similarly, reducing power. Greater the reducing power, greater the tendency to reduce something else, greater the tendency to undergo oxidation within itself. So oxidation potential should be highest. So greater the oxidation potential, greater will be the reducing power. Reactivity of metals, understand this. Reactivity of metals is directly proportional to SOP. Why? Metals has a tendency to undergo loss of electrons. So metal, if it is undergoing loss of electron, what you can say? Like
Its oxidation potential is
oxidation potential is high. So wherever the oxidation potential of the metal is high, it will undergo the loss of electron greatly. If it undergoes the loss of electron greatly, it is forming respective ions fastly. So it is going to be more reactive. So reactivity of metals is again directly proportional to SOP. So greater the tendency to undergo oxidation, greater will be the reactivity of the metal. In electrochemical series, reactivity of metals decreases from top to bottom. Reactivity of metals decreases from top to bottom. Why? Because lithium has a greatest, because top metals have greatest SOP. SOP I'm talking about, not SRP. SRP is least, so SOP is greater. So lithium is most reactive because Li will be forming respect to Li plus and electron. Although lithium is having the greatest standard reduction potential, it will not react with water greatly because it forms hydrated. Li plus is going to be aqueous. In the aqueous state, it is going to be hydrated. So Li is most reactive based on SRP values because it will be having the least SRP. So highest SOP means higher the tendency to undergo oxidation. Higher the tendency to undergo oxidation, obviously it will be having higher reactivity. So this is the reactivity of metals. Reactivity of metals directly proportional to SOP. Non-metals, think of non-metal like fluorine. Non-metals has to undergo, fluorine will take up the electron to form F minus, reduction. So reactivity of non-metals is directly proportional to SRP. So in electrochemical series, reactivity of non-metals is decreasing from top to bottom or increasing from top to bottom?
increasing from top to bottom.
Increasing. Like in electrochemical series, reactivity of non-metal increases from top to bottom because SRP values are increasing. As SRP values increases. And F2 is the most reactive metal because F2 will take up 2 electron to form 2F minus and SRP is plus 2.87. Right? metals above hydrogen displace H2 from dilute acid solution. Understand this point carefully. So where is the standard hydrogen electrode? Here it is. Metals above hydrogen like lead, tin, nickel, cobalt, cadmium, all these metals above hydrogen, they will displace H2 from dilute acid solution. That means, like, let us take first reaction Zn plus H2S4. Zn plus H2SO4 is forming ZnSO4 plus H2. I'm saying, if I say Zn plus H2S4 is forming ZnSO4 plus H2, what are the reactions happening? Zinc is undergoing a change of Zn converting into Zn plus 2 electrons. 2H plus will take up those 2 electrons to form H2 gas. For this change, what is the total cell reaction? E of cell is equals to, like, E naught of cell is equals to, under standard conditions, E naught of Zn to Zn plus 2 plus E naught of H plus 2 H2. Yeah, E naught of Zn to Zn plus 2, is that positive or negative?
Positive.
Positive. E naught of H plus 2 H2 is 0 because Zn is above hydrogen, right? Zn is above hydrogen. So for that, all elements present above hydrogen, E naught of Zn to Zn plus 2 is positive. E naught is positive means what happened to delta G? Delta G naught is equals to minus NF E naught. How do we get this? Because there are different kinds of work. Whenever the charge has been transferred, some electrical work has been done. What is the electrical work done? Electrical work is equals to electrical work done is equals to charge into potential developed. Charge into potential. What is the charge? Let us say n farads of charge. What is the potential? Electrical potential E. Under standard conditions E naught, NF E naught. The electrical work, whatever has been done, that will decrease the Gibbs free energy. Electrical work done will decrease the Gibbs free energy. Whatever the decrease in Gibbs free energy minus delta G, decrease in Gibbs free energy is minus delta G. Minus delta G naught is equals to NFE, or you can say delta G is equals to NFE naught. So delta G has to be positive, or delta G has to be negative, means E naught has to be positive. Delta G negative means delta G naught is equals to minus NF E naught. Delta G naught, that should be is equals to minus number of electrons change, that is positive, F is positive, E naught is positive, so delta G is negative. So whenever we have E naught of cell is going to be positive, that condition delta G naught is negative. Delta G naught negative means it is a reference of spontaneity. So for all the metals above hydrogen, the E naught of cell is going to be positive. If E naught is positive, delta G naught is negative, so that can be spontaneous. So I can say generalized statements: metals above hydrogen displace H2 gas from the dilute solution where we have H plus ions. Understood this point or not? Metals above hydrogen can displace H2 gas from the dilute acidic solution because Zn plus H2S4 is forming ZnSO4 plus H2. But if you go with the other series, like other elements, like below H2 we have copper, let us say. So for copper cannot displace hydrogen. Cu plus H2SO4 does not give CuSO4 plus H2. Why? Because it has, if you can see the SOP for Cu plus 2 to Cu, it will be negative. E naught is negative means delta G naught will be positive. So it is non-spontaneous in nature. Metals above hydrogen displace H2 from dilute solution. So zinc plus H2S4 forms ZnSO4 plus H2. Copper plus H2S4, it will not form any reaction, no reaction. Right? Not only with respect to H2. Now, until now, we have compared with respect to H2. But what I can say is metals above a particular metal, like a particular metal X is there, above X we have some set of metals. The metals above X can displace X from its aqueous solution because E naught of the reaction has to be positive. With respect to non-metals, what I can say, non-metal below a particular non-metal can displace that from the aqueous solution. Like look at these reactions. Copper and AgNO3. I have placed the copper rod in AgNO3. More reactive metal or non-metal displaces less reactive metal or non-metal from the solution. So these are the equation happening. Cu plus 2 AgNO3 is forming CuNO3 taken twice plus 2 Ag. So what are reactions involved? Cu converting into Cu plus 2 electrons, and 2 Ag plus will take up 2 electron to form 2 Ag. So what is the E naught of cell? E naught of cell is equals to E naught of Cu to Cu plus 2 plus E naught of Ag plus 2 Ag. What is E naught of Cu to Cu plus 2?
minus 0.34.
Cu plus Cu to Cu plus 2 is minus 0.34. Ag to Ag plus is minus 0.34. And Ag plus 2 Ag is how much? Plus 0.80. So E naught of cell is positive ultimately. So E naught is positive means delta G naught negative. E naught is positive means delta G naught negative. Delta G naught negative means that is going to be respective. Delta G naught is negative, so spontaneous. Spontaneous. So delta G naught is positive, non-spontaneous. Understood this point or not? So you may ask a question now, sir, how do we know the electrode potential values? You have to just know the order. You don't need to remember the values, but you have to at least know the order, like which element is above, which element is coming down. That order at least you have to know. If not, you cannot answer this, no. I'm not asking you to remember the values. At least remember, like for zinc, for copper, for some standard electrodes, you can remember, but not for every particular electrode. But you have to know the order, like which elements are above and which elements are below hydrogen and how are they placed. Clear, students?
Yes, sir.
Yes, right. So if standard reaction potentials of A, B, C, and D are given respectively, then arrange these elements in the decreasing order of oxidizing power and reducing power. So reduction potential is given. So reduction potential means A plus electron gives rise to A, given as minus 1.5. B plus electron gives rise to B, given as plus 2.5. C plus electron gives rise to C, minus 0.5. D plus electron gives rise to D, given as 0.8. Oxidizing power is directly proportional to tendency to oxidize something else,
RP.
means tendency to undergo reduction. So SRP greatest for
B.
B, then D, then C, and then A. So reducing power, opposite, right? Exactly opposite. Okay, based on SRP values, you can compare what is the respective oxidizing power and reducing power for the respective species given to you. Sodium can displace which of the following cation from its solution? Sodium can displace which of the following cation means below sodium, which is there, like more reactive metal can displace less reactive metal. Below sodium, what is there?
Potassium.
Below sodium, whatever the element is there, that can be displaced by sodium, right? So you have to check out below sodium what is there from the electrochemical series. If you go with the order, which is present below sodium? Zinc. Asma Khan says zinc. Very good. So Zm plus 2. Consider the following reactions for EMF of a electrochemical cell. Consider the following relations for EMF of a electrochemical cell. EMF of a cell is equals to oxidation potential of anode plus reduction potential of cathode. Reduction potential of anode plus reduction potential of cathode. Oxidation potential of anode minus oxidation potential of cathode. Which of the following relations are correct?
Option 4.
Oxidation potential of anode plus oxidation reduction potential of cathode, A is correct. And oxidation potential of anode minus oxidation potential of cathode, A and C are correct. So option 4. Right. The standard reduction potential values Al plus 3 electrons converting into Al, given as minus 1.66. Ag plus electron gives rise to Ag, given as plus 0.8. K plus electron gives rise to K, given as minus 2.93. Cr plus 3 electron gives rise to Cr, given as minus 0.74. The correct decreasing order of reducing power. Reducing power is directly proportional to SOP, right? Tendency to reduce something else. That means tendency to undergo oxidation within. So which can undergo oxidation greatly? Potassium K. Then because K to K plus will be my plus 2.93. After that, aluminum to Al plus 3 is plus 1 aluminum. After that, we have chromium. After that, we have silver. That will be the right order. K greater than aluminum, greater than chromium, greater than silver. That will be the right order of your reducing power. Such questions are very famous, so mostly asked. Very easy question, you can answer them. Then comes the next topic, construction of the cell. We have to construct a cell. How the cell has been constructed? So we have taken a particular beaker, like let us look at Daniel cell. We have placed zinc rod in ZnSO4, and we have taken another beaker. We have placed copper rod in CuSO4, zinc rod in ZnSO4, copper rod in CuSO4. So what happened? Zinc will undergo oxidation. Zinc will come from the zinc rod as Zn plus 2 ions. So extra negative charge is present on the zinc rod. So whenever I connect the zinc rod with the copper rod with the help of a conducting wire, what happens? Flow of electrons occurs. Because of flow of electrons, bulb glows, and the potential developed here is E of cell is 1.1 volt, and the electrons whatever present here, they will be taken by Cu plus 2 ions and copper plus 2 from the solution that will deposit as copper on the electrode. This flow of electron will happen only for a very small time if the circuit is incomplete. To actually have this flow of electrons, we should have the circuit to be complete. The circuit is completed with the help of salt bridge. In the salt bridge, the role of salt bridge is to actually complete the circuit and actually maintain the electrical neutrality. Why? Because in ZnSO4, like 100 ZnSO4 molecules to take, we get 100 Zn plus 2 and 100 sulfate. We place zinc rod in ZnSO4. Zinc from the solution went into zinc from the zinc rod went into solution as Zn plus 2. So extra positive charge is there. To neutralize the extra positive charge, we need negatively charged ions. They are provided by salt bridge. Salt bridge provides complete circuit, electrical neutrality, and it will not allow the flow of ions from one half cell to the other half cell. It is not supposed to allow the flow of ions from one half cell to the other half cell. If that is happening, it is not, the cell itself is losing its nature. And inside the salt bridge, we have some jelly substance so that the ionic movement has been transferred. Ionic movement is not allowed, and also it will be made in such a way such that the liquid-liquid junction potential is also not going to be developed, because one liquid and the other liquid when you keep, there's a possibility of developing of liquid-liquid junction potential. That's why some woolen substances have been placed at the end also, so to minimize the liquid-liquid junction potentials. And also whatever the ions which are passed into ZnSO4, to neutralize the positive charge, they should not be reacting with the ZnSO4. If there is some ion provided by salt bridge for electrical neutrality, but that is going and reacting with the electrolyte present in the half cell, then that is not a correct ion to be taken in the salt bridge. Like you cannot take KCl whenever we have silver electrode, because Ag plus ions will react with chloride ions to form HgCl, which is a precipitate, which is not accepted because that will change the concentration. Right? Is everything clear or not?
Yes.
Yes. Now the question to you is, will the flow of electron occur continuously? Like I have placed zinc rod in ZnSO4, copper rod in CuSO4, complete the circuit, everything is done, construct the circuit, construct the cell. Now will the flow of electrons, like will the glow of bulb is continuous until the rods have been lost? Everyone understood the question or not? I have completed the circuit. oxidation is happening, reduction is happening. But will the flow continuous? Is the flow continuous, or is there a limit up to which the flow occurs?
Sir, limit.
Why? On what basis?
Sir, as ions will dissociate, it will inhibit the flow of electrons. Like Zn plus 2 will dissociate, so it will form attraction with the electrons, a negative charge of anode, which will further inhibit the release of Zn plus.
No, that's why the wire is there. No, the negative charge in anode is not present for a long time. Once the metallic wire is connected, the extra electric charge is, the extra electrons are simply moving out. So whatever the Zn plus 2 extra you are saying, they are actually neutralized by the ions given by the salt bridge, the oppositely charged ions. So there is no extra charge in the any half cell. That has to be neutralized with the help of salt bridge. And there is no extra charge, extra negative charge in anode, because it is flowing out continuously to the cathode. Okay, so I'll understand. I'll say one perspective. So at anode, what happens? At anode, understood, Faizan, or not? Okay.
Yes, sir.
Whatever the dissociation you're talking about, that is not present over a long time, because the extra positive charge is neutralized immediately by salt bridge ions, and the negative charge present on the anode has immediately transferred to the cathode. Flow of electrons is very fast. At anode, what happens? Zinc rod mass decreases. Zn plus 2 concentration or ZnSO4 concentration
Increase.
increases. At cathode,
CuSO4 concentration decreases.
copper rod mass decreases. Copper rod mass increases and CuSO4 concentration decreases. Copper rod mass increases, CuSO4 concentration decreases. Whenever the concentration has been changed, is the electrode potential same or differed? Are you understanding these points or not? The electrode potential of Cu plus 2 to Cu plus 2 plus 2 electron converting to Cu, that is 0.34, is only under the standard condition. But as the electron flow is happening, what actually is undergoing? I have taken 1 molar CuSO4, I have taken 1 molar ZnSO4, everything is fine at time t is equal to 0, where I have started the experiment. But as the flow of electrons from the zinc rod to the copper rod is happening, the concentration of CuSO4 is actually decreasing and the mass of copper rod is increasing. If the concentration of CuSO4 is decreasing, it is no more 1 molar. If it is no more 1 molar, is that going to be the is it undergoing the standard condition? Is the electrode potential to be standard condition throughout? No, only in the initial time it is standard condition. But what happens when the concentration has been changed? The electrode potential changes. So how the electrode potential changes with respect to concentration, that was given by Nernst equation. What is Nernst equation is? So just let us understand that particular point. So Nernst equation actually tries to say delta G is equals to delta G naught plus 2.303 RT log Q. Delta G is what? Minus NF E of cell is equals to delta G naught is minus NF E naught of cell plus 2.303 RT log Q. So E of cell is equals to what? E of cell is equals to E naught of cell minus 2.303 RT by NF. 2.303 RT by F is 0.0591 by N into log Q. Now let us take the scenario of zinc rod placed in ZnSO4, like I am talking about anodic half cell. Metal in the solid state is converting into Mn plus ion plus N electrons have been transferred. So E of M2 Mn plus, that is oxidation potential, is equals to E naught of M2 Mn plus minus 0.0591 by N is nothing, number of electron transferred is N, into logarithm of what is Q for this scenario?
Mn plus upon M.
What is the concentration of M in the solid state?
Solid 1, solid 1.
Because it is unit, right? So concentration of Mn plus. So initially the standard potential you know, but what happens as the concentration of Mn plus is increasing? Can I say concentration of Mn plus increasing means negative 0.0591 by N into logarithm of concentration of Mn plus, that is decreasing. That means E of M to Mn plus is decreasing. So tendency to undergo oxidation is decreasing or not?
Yes.
Yes.
Are you understanding this point? M2, the metal solid M is converting into Mn plus N electrons. This is Nernst equation. You have to understand this point now only. Nernst equation is not something else. It is the same because as the time proceeds, what happens? The concentration of Mn plus in the anodic half cell. This is in the anodic half cell. In the anodic half cell, the concentration of Mn plus is increasing because time proceeds means more Zn plus 2 ions are coming from the zinc rod to the solution. So concentration of Mn plus increasing means minus 0.059 by n into logarithm of Mn plus is decreasing. If this value is increasing, obviously E naught is going to be, if this value is increasing, obviously E naught is decreasing. E naught is decreasing means what?
E of cell is decreasing.
E of cell is obviously decreased. So ultimately the tendency to undergo oxidation is decreasing. Ultimately, the reaction is not going to happen until all the rods has been dissociated or all the zinc rod. You will not say zinc rod is vanished after some time. That is never going to happen because there is a saturated stage where you will not be having further oxidation, or there is a saturated stage where there will not be having further reduction. Okay.
Yes, sir.
Same with respect to cathodic half cell also, you can say in the cathodic half cell we have another rod M1 aqueous ion like M dash, let us say M dash in the aqueous state, that is taking up n electrons to form M dash in the solid state. So E of M dash 2, like here we have M dash of n plus, right? Or you can say let us some n, instead of confusing, n plus n electrons gives us to n solid. M of n plus to n is equals to E naught of n plus to n minus 0.0591 by n into logarithm of 1 by concentration of n plus. So that is equals to E naught of n plus to n plus 0.0591 by n into logarithm of concentration of n plus, E of n plus to n. So concentration of n plus increasing means what? Concentration of n plus increasing means E of n plus to n is high. Concentration of n plus is decreasing or increasing over time for copper rod?
Decreasing.
Concentration of n plus is decreasing. So E of n plus to n will be decreasing. So whatever the cell you have constructed, that will not be happening or working for infinite number of time. If it works for infinite amount of time, then that would be a great source of electrical energy, but that is not going to happen. Right. So from the zinc rod, we have electrons traveling to the copper rod. Bulb is glowing. E of cell is 1.1 volt. It is Daniel cell. Zinc can undergo oxidation. Zn plus 2 electron. Copper plus 2 plus take up the 2 electron to form copper. And whenever you place a salt bridge, then only again the flow of electrons occurs, because salt bridge will complete a circuit as well as it maintains the electrical neutrality, and the whatever the ions we have taken in the salt bridge, they should not be reacting with the electrolytes in two half cells, and also it should prevent the liquid-liquid junction potential. Right. Salt bridge is an inverted U-shaped glass tube containing solution of inert electrolyte like KCl, KNO3, NH4NO3 with the agar-agar jelly or gelatin to convert electrolytic solution into semi-solid form. Its functions are these. What are its function? It connects the solution of two half cells to complete a circuit. Circuit has to be completed for the flow of current. It maintains electrical neutrality of solution in order to give continuous flow or generation of current. If the electrical neutrality is not disturbed, then obviously continuous flow is not happening. If the salt bridge is removed, then voltage drops to zero. It prevents the liquid-liquid junction potential, the potential difference which arises between the two solutions when they are brought in contact with each other. Is that clear, students? Is everything clear so far?
Yes, sir.
Yes, right. Then we also say that ions of inert electrode do not involve in any chemical change. If Ag plus, Hg2 plus, Pb plus 2, Tl plus ions are present in a cell, then KCl is not used. Why? In the salt bridge, we should not use KCl because there can be a formation of precipitates. Okay. The electrolyte in salt bridge should be such that the speed of its cation and anion should be neutral, like 1:1 type of, okay, mostly 1:1 type of electrolytes are preferred, because for every one cation, if you are getting two anions, for every one cation, if you are getting two anions, then obviously that will not be having the great effect, right? So mostly 1:1 type of electrolytes are preferred for this type of solution. So those are the respective properties of the salt bridge. So this is nothing but a Daniell cell. And now if someone asks you to represent a Daniell cell, do I need to always draw the circuit and place two beakers, two rods, connect them, salt bridge, all this diagram, it takes a lot of time, right? So instead of drawing all this figure and all, so there is some representation or cell notation. So in the shortcut itself, we can understand how to represent a particular galvanic cell. So there are some set of conditions, cell representation. We require two half cells to produce an electrochemical cell, which can be represented by following rules. Like anodic half cell, we have to place first, then salt bridge, then cathodic. In the anodic half cell, oxidation occurs. In the cathodic half cell, reduction occurs. The separation of two phases or states of matter is shown by a vertical line. In the anode, zinc rod is placed in ZnSO4. Zinc is in the solid form. Zn plus 2 is in the aqueous form. So these two are separated by a vertical line. Same in the cathode, Cu plus 2 aqueous is converting into Cu solid. Again, they have to be separated by solid vertical line. The various materials present in the same phase are shown using commas. If a same phase materials are there, they can be shown using commas. And the pressure, temperature, concentration, they can be measured after the respective ion. Like when write its concentration C1 molar, then salt bridge, its concentration C2 molar. So this is your anodic part and this is your cathodic part. Is that clear or not? The anodic half cell is always written, followed by cathodic half cell. The two half cells have been separated by a salt bridge. Within the half cell, whatever different phases you have, they are separated by a vertical line. If you have materials in the same phase, they are indicated using commas. Concentrations or pressures, they were written after the respective species in the bracket. The salt bridge is represented by a double vertical line. The significant features of substances like pressure of a gas, concentration of ions are indicated in brackets. Like this is how you can write Zn solid. Zn solid is converted into ZnSO4 means Zn solid. It is solid state. Zn plus 2 is aqueous phase. Let us say C1 molar salt bridge, Cu plus 2 aqueous phase, C2 molar, let us say, and Cu solid. So this is how you can represent a particular cell. You try to represent, write cell representation for the following reaction. First one we have already done. You do second one. Second one I can write anodic half cell first. Zn solid converting into Zn plus 2 aqueous. No concentration mentioned, so we can directly place the salt bridge. H plus aqueous converted into H2 gas. Third one, H2 is converted into H plus, H2 gas, different state, H plus aqueous, different phase. We all know that the stoichiometric coefficient will not change the electrode potential. We don't need to place them. Salt bridge, Cu plus 2 aqueous, Cu solid. What about fourth? Fe plus 3 plus Zn. Zn solid is converting into Zn plus 2 aqueous, salt bridge, Fe plus 3 aqueous, comma, Fe plus 3 is converting into Fe plus 2 aqueous. Here I have mentioned comma because Fe plus 3 and Fe plus 2 both are in the aqueous phase. So same phase means you have to, same phase means you have to indicate with just a comma, not a vertical line. Got it or not?
Yes, sir.
Try to solve next question. Lot of problems you have to solve with respect to these all physical chemistry chapters. Then only you will get more comment. For following same platinum H2 H plus Ag plus 2 Ag, write cell equation or cell reaction. Anode, what happening? Anode means oxidation occurs. So H2 is converting into 2H plus and 2 electrons. Cathode, Ag plus will take up an electron to form Ag. So 2Ag plus 2 electron gives us 2Ag. Cell reaction. In the cell reaction, make sure that there are no electrons present. 2 electron gets cancels out. H2 plus 2 Ag plus gives rise to 2H plus 2 Ag. This is nothing but your cell reaction. Is that clear or not, students?
Yes.
Yes. Given cell, write the cell reaction. Simple. Cr solid is converting into Cr plus 3 electrons. Fe plus 2 electrons is converting into Fe solid. Fe plus 2 is aqueous. So I multiply with 3 here. 3 Cr gives us 2. 2 Cr gives us 2 Cr plus 3 plus 6 electron. Or I'll indicate the multiplication again later. I'm multiplying this with 2. I'm multiplying this with 3. Then you can try to add 2 Cr plus 3 Fe plus 2 gives rise to 2 Cr plus 3 plus 3 Fe. These are in the solid state and the other is in aqueous phase. This is a cell reaction. Right. E naught of Zn to Zn plus 2 given, E naught of Fe to Fe plus 2 also given, E naught of the following cell. E naught of cell is equals to, in the cell what is happening? E naught of zinc is converting into Zn plus 2 and E naught of Fe plus 2 is converting into Fe. Zn to Zn plus 2 is given as 0.76. Fe to Fe plus 2 is given as 0.40. Fe plus 2 to Fe is how much? Minus 0.40. So that becomes 0.36 with a positive sign. Very simple questions. Two metals X and Y are connected to prepare a galvanic cell. A galvanic cell has been prepared with two metals. The standard electrode potential of X and Y are given. So let us take these are SRP metals. X is taking up an electron to form X plus. Here the value is minus 0.30. Y plus is taking up an electron to form Y. Here it is given as plus 0.14. But here you have to understand carefully that here instead of writing this, I have to write X plus plus. X plus is giving X plus electron. Like X plus plus electron is giving X. Because they have mentioned just electrode potential, not the standard reduction potential or oxidation potential. So when nothing has been mentioned regarding electrode potential, you have to take reduction potentials only. Reduction potentials. And now I have to consider which species undergoing oxidation, which species undergoing reduction. Which will undergo oxidation?
First one oxidation.
First one oxidation because the E naught of the total cell has to be positive. So E naught of cell is equals to E naught of X to X plus E naught of Y plus 2Y. You can take other way also. First one reduction, second one oxidation. In that way, you get total E naught is going to be negative. So whatever the cell you have predicted, in the exactly opposite direction, the flow of current is happening. x to x plus is 0.30, y plus to y is 0.14. So that will be plus 0.44 volt. Plus 0.44 volt, that is the respective E naught of cell for this particular equation or for this particular reactions. Is that clear, students?
Yes, sir.
Yes, sir. Yes, sir.
Yes. So then work done by cell, this is what I have told you. Delta G naught is equals to minus NF E naught. Work done, electrical work done is charge into potential. NF into E is the work done, and that work done will decrease the Gibbs energy. So minus delta G is equal to NFE, or delta G is equal to minus NFE. These under standard condition. Under normal condition, delta G is equals to minus NFE. And we all know under standard condition, delta G naught is equals to minus NF E naught of cell, and delta G is equals to minus NF E of cell. Delta G is equal to minus NF E of cell, delta G naught is equals to minus NF E naught of the cell. So E naught of the cell has to be positive. E naught of the cell, E naught of the cell has to be greater than 0, or you can say with respect to E of cell, E of cell should be greater than 0. So delta G of cell should be greater than 0, should be less than 0. If delta G of the cell is less than 0, then that condition is said to be spontaneous condition. So spontaneity, cell reaction is spontaneous if delta G is negative. Delta G negative means E naught is E is positive. Non-spontaneous means delta G is positive. Delta G positive means E of cell is going to be negative. Cell reaction will be in equilibrium if equilibrium means delta G is equal to 0. Understand the concept of equilibrium. Delta G is 0, E of cell 0, but not E naught and not delta G naught. Delta G naught is not 0, E naught is not 0. Delta G naught is not 0, E naught of cell is not 0. Delta G and E are 0. Delta G is equal to 0, E is equal to 0 under equilibrium. Delta G naught is not equal to 0. E naught of the cell is not equal to 0. It doesn't mean like, sir, can we made a reaction where delta G naught is also equal to 0? Yes, you can made it. You can make delta G naught equal to 0 by changing the value of K. Like equilibrium constant is going to be changed, right? But under normal condition, delta G naught is not 0, E naught is not 0. But if I want to prepare a cell such that delta G naught is also 0, then I can do it. But it is not for all types of cells. For all types of cells at the equilibrium, delta G is 0 and E is 0. Delta G is what? Delta G is equals to delta G naught plus 2.303 RT log Q. At equilibrium, what happens? At equilibrium, delta G is 0.
Zero.
Q is equals to K. So 0 is equals to delta G naught plus 2.303 RT log K. So delta G naught is equals to minus 2.303 RT log K. And what is delta G naught? Delta G naught is also equal to minus NF E naught. Minus NF E naught is equals to minus 2.303 RT log K. Minus minus gets cancelled. So E naught is equals to how much? 2.303 RT by NF into log K. This value is 0.059. E naught is equals to 0.0591 by N into log K, right? Into log K to the base 10. This is nothing but your E naught of the cell. Delta G naught is equals to minus 2.303 RT log K. E naught is equals to 0.0591 by N into log K to the base 10. Is that clear, students?
Sir.
So these are the different equations which I have already explained. You can see all these equations again in the upcoming slides. There you can easily understand. Calculate the standard EMF of this cell. Standard EMF of this cell, delta G naught is given. Delta G naught is equals to what? Minus NF E naught. Standard EMF E naught they are asking. E naught is equals to minus delta G naught by NF. What is minus delta G naught? Minus of minus 2746 kilojoule divided by N into F. What is N? N is the number of electron change. So valence factor is equals to change into valence factor is equals to change into number of atoms. I can write like this, number of atoms. So oxygen from the 0 state went to -2 state, -2 state. How many oxygens are there? 13 by 2 into 2, 13 oxygens. What is the change? Change is 2. 2 into 13, that is nothing but 26. So number of electrons involved in the change is 26 into F Faraday's 96,500. So E naught is equals to minus 2746 kilojoule divided by 26 into 96,500 coulomb. You can try to solve it. You will be getting the ultimate answer. Clear or not?
Yes.
Yes. Then comes Nernst equation. This equation already have explained. Same, delta G is equal to delta G naught plus RT ln Q. This is the equation used whenever the concentrations or the pressures, they are different when compared to the standard condition. It gives relation between electrode potential or EMF of the cell and concentration of the electrolytic solution. Nernst derived relation between free energy change delta G and reaction quotient Q. Delta G is equal to delta G naught plus RT ln Q. Delta G is the free energy change. Delta G naught is the standard free energy change. Q is the reaction quotient. Delta G is equal to minus NFE. Delta G naught is equals to minus NFE naught. We have this relation delta G is equal to delta G naught plus 2.303 RT log Q. Here they have mentioned with respect to ln. I am writing it in terms of logarithm. So delta G is minus NFE. Minus NFE is equals to minus NFE naught plus 2.303 RT log Q. So E is equals to E naught minus 2.303 RT by NF log Q, or E is equals to E naught minus 0.0591 by N into log Q. E is equals to E naught minus 0.0591 by N into log Q. This was the relation. Nernst equation. So log Q is going to be changing. So if you remember, with respect to this equation only, I have told you, like the transfer of electron from the anode to the cathode is not 100% continuous. It is not going to happen for infinite time. Yes or no? Because the Q value is going to be changing. The E of oxidation and E of reduction are going to be changing. Subsequently, with respect to that, whether the electron flow is happening continuously or not, that can be judged. With respect to that, whether the electron flow is happening continuously or not, that can also be judged. Right. So this is a Nernst equation. The same equation you can see now. Thus from equation 1 and 2 we can have minus NFE is equals to minus NFE naught plus RT ln Q. So or E equal to E naught minus 2.303 RT by NF into log Q. Or you can write the same expression as at 25 degrees Celsius, 2.303 RT by F is 2.303 into R 8.314 into T 298 divided by 96,500. That is equal to 0.0591. So E is equal to E naught minus 0.0591 by N into log Q. That is called as your Nernst equation. That is called as your respective Nernst equation. And Q is the product of like concentration of products raised to the power of stoichiometric coefficients divided by concentration of reactants raised to the power of stoichiometric coefficients. That is nothing but your Q value. Applications of Nernst equation. Calculation of electrode potential. Electrode potential you can calculate like M plus Mn plus N electron gives us to M. Can I say this is a reduction potential because reduction happening, E reduction potential is equals to, or you can also write as E of Mn plus to M is equals to E naught of Mn plus to M minus 0.0591 by N into logarithm of 1 by concentration of metal in the solid state is 1 unity, 1 by concentration of Mn plus. I can write the same expression as E of Mn plus to M is E naught of Mn plus to M plus 0.0591 by N into logarithm of concentration of Mn plus. Can I say if the concentration of Mn plus is increasing, E naught will be high?
Yes.
concentration of Mn plus, if it is increases, E naught of Mn plus to M will be high. That will increase. Concentration of Mn plus decreases, E of Mn plus to M is decreasing. Let us take copper, because we all know in the Daniell cell Cu plus 2 electron converts to Cu. Concentration of Cu plus 2 is decreasing or increasing over time?
Decreasing.
Concentration of Cu plus 2 decreasing means what happened to E of Cu plus 2 to Cu? That is
Decreasing.
also decreasing. So tendency to undergo the reduction is also decreasing over time. If a concentration of Mn plus increase, then E of reduction potential increases. If concentration is decreasing, then reduction potential is going to be decreasing. So calculation of electrode potential for unknown electrode. For unknown electrode, we'll use the same technique. Using standard hydrogen electrode only we can calculate. Like E of Cu plus 2 to Cu plus E naught of H2 to H plus, this is equal to reading. So H2 to H plus is 0 because it is SHE. Calculation of electrode potential and pH of hydrogen electrode. How to calculate this? Calculation of electrode potential and pH of hydrogen electrode. Let us take the scenario 2H plus 2 electron is giving to H2 gas. 2H plus is plus 2 electron is giving to H2 gas. E of reduction potential I can write as E of H plus to H2 is equals to E naught of H plus to H2 minus 0.0591 by N, number of electron transferred is 2, into logarithm of H2 is a gas, so I have to include its partial pressure of H2 divided by concentration of H plus whole square. So E naught of hydrogen electrode, that is 0, standard electrode, 0 minus 0.0591 by 2 into logarithm of, let us take the condition of partial pair of H2 is equal to 1. If okay, 1 by concentration of H plus whole square, if partial pair of H2 is equals to 1 atmosphere. So E of H plus to H2 is equals to plus 0.0591 by 2 into 2 times that of logarithm of concentration of H plus. 2 gets cancels. I can say E of H plus to H2 is equals to minus 0.0591 into negative logarithm of H plus is pH. So E of reduction potential is equals to E of H plus to H2 is equal to minus 0.0591 into pH, or you can also write E of H2 to H plus how much? Oxygen potential
Plus 0.059.
plus 0.0591 into pH. Like for the same electrode, oxygen potential and reduction potential are same, just with a minus sign difference. This is how you can write the pH relation with respect to hydrogen electrode. So E reduction potential is minus 0.0591 pH, or E oxygen potential is plus 0.0591 pH. Calculation of EMF of cell. So for this particular cell, how you can write? E of cell is equals to, how you can write? E of cell is equals to E naught of cell minus 0.0591 by N into log Q. What is Q for this reaction? Concentration of Zn plus 2 divided by concentration of Cu plus 2. Concentration of Zn plus 2 is increasing over time. Concentration of Cu plus 2 is decreasing. This is increasing, this is decreasing. What happened to this value, total value?
Constant.
Both are increasing means it can be constant, right?
Decrease. Increase.
Like,
Decreasing, negative value decrease.
see, A by B, A value is increasing, it becomes 2A. B value decreasing, it is becoming 2A by B by 2. What happens? 4 times
It
of A value.
increases.
Or A by
Or same thing. This Q is going to be increasing or decreasing?
Increasing.
Q is going to be increasing. If Q is increasing, this negative value is decreasing. So what happened to E of cell? E of cell is decreasing.
Decreasing.
increase.
So ultimately, the E of cell is decreasing as time is proceeding. We can say with respect to time interval in that way, or with respect to two half cells. If concentration of Cu plus 2 increases, then E of cell increases. If concentration of Zn plus 2 increases, then E of cell decreases. These are the perspectives. With respect to that also we can comment. right? Next, we can also think of prediction and feasibility of reaction. Simple, delta G has to be negative, E has to be positive. Under that condition, we can say spontaneous reactions. So for a feasible cell reaction, delta G has to be negative, E of cell has to be positive. Since delta G is equals to minus NFE, under that condition only we can have the reaction is going to be spontaneous in nature. And delta G and the Q relation we can also have, that is the next relation. Calculation of equilibrium constant. We all know delta G naught is equals to minus 2.303 RT log K. And also E of cell, E naught of cell is equals to 0.0591 by N into log K. Earlier we have derived the relation, no? Delta G naught is equal to minus NF E naught. E naught is equals to 2.303 RT by NF. 2.303 RT by F is nothing but 0.0591. So from that you get this relation. From Nernst equation you can say delta G naught is equals to minus 2.303 RT log K. And also from that you can say, with respect to this, what you can say, what is the relation of logarithm? Like log x curve. How the log x curve is? Log x is equals to, can log x be positive? Log x is undefined. For x belongs to minus infinity to
0, minus 1.
0 included. Log x is negative. X belongs to 0 to
0
1.
to 1.
1 excluded. Log x is 0. X equal to 1. Log x is positive. X belongs to 1 to infinite. So now look at the delta G naught value. Delta G naught is like with respect to K equilibrium, you comment. K equilibrium is greater than 1. Like K equilibrium greater than 1 means logarithm of K equilibrium is positive. Yes or no? Because log x is positive when x belongs to 1 to infinity. So K equilibrium greater than 1 means log K equilibrium should be positive. Logarithm of K is positive means what happened to delta G naught? Delta G naught means minus
Negative.
of positive into positive into positive. So that becomes delta G naught is negative. Delta G naught negative means it is spontaneous. Spontaneous means what is K equilibrium? K equilibrium means product of concentration of product by product of concentration of reactants. This is greater than 1. So concentration of products greater than concentration of reactants. Yes or no? Since it is spontaneous, the products are more in concentration when compared to reactants. If K equilibrium is less than 1, E naught of cell is going to be negative. Because why is E naught is going to be negative? Because delta G naught will be positive. Then under that condition, we can say the cell is non-spontaneous. So with respect to K equilibrium also, we can talk of spontaneity. K equilibrium greater than 1, delta G naught would be negative spontaneous. K equilibrium less than 1. K equilibrium less than 1 means delta G naught is going to be positive non-spontaneous. And with respect to log K and E naught, we can comment. K equilibrium greater than 1, E naught is positive. K equilibrium less than 1, E naught is negative. Right? E naught is equal to 0.059 by N into log K equilibrium. Delta G naught is equals to minus 2.303 RT log K. K equilibrium greater than 1. E naught is positive. Delta G naught is negative, spontaneous. And we can also say in this condition, concentration of product is greater than concentration of reactant. K equilibrium less than 1. E naught of cell is negative. Delta G naught is positive, non-spontaneous. So in that condition, you can say concentration of product is less than concentration of reactant. So more reactants are there, so reaction is non-spontaneous. More products are there, so reaction is spontaneous. So that was your ultimate conditions or relations with respect to your Nernst equation. Right? Calculate the EMF of Daniel cell when the concentration of ZnSO4 and CuSO4 are 0.001 molar and 0.1 molar respectively. The standard EMF of the cell is 1.1 volt. So what is Daniel cell happening? In the Daniel cell, we have zinc solid is converting into Zn plus 2 aqueous plus 2 electrons Cu plus 2 aqueous plus 2 electrons gives Cu solid. So what is the complete equation? Zinc solid plus Cu plus 2 aqueous is giving Zm plus 2 aqueous plus Eu. So E of cell is equals to E naught of cell minus 0.0591 by n number of electron transferred is 2 into logarithm of Q is concentration of Zm plus 2 divided by concentration of Cu plus 2. They have given standard EMF of cell is 1.1 volt, 1.1 minus 0.0591 by 2 into logarithm of concentration of Zm plus 2 how much? 10 power minus 3. Cu plus 2 is 10 power minus 1. So 10 power minus 2 times cancels out. So 1.1 minus 0.0591 by 2 into logarithm of 10 power minus 2 is minus 2. 2 gets cancels. So 1.1591. E of cell is equals to 1.1 plus 0.0591 is 1.1591. Is that clear now?
Yes, sir.
Yes, right. Calculate D naught and E for cell. Sn to Sn plus 2 1 molar, Pb plus 2 10 power minus 3 molar to Pb. E naught is given Sn plus 2 Sn. Pb plus 2 Pb is also E naught given. Is cell representation correct? Look at the cell representation first. First they have salt bridge. Before the salt bridge we have anodic part and then we have cathodic part. Sn to Sn plus 2 concentration represented properly. Pb plus 2 to Pb concentration again represented properly. So cell representation correct. Cell representation is correct. So we have to understand now E of cell, right? So what is cell actually? Sn is converting into Sn plus 2 electron. Pb plus 2 is taking up the 2 electron to form Pb. Sn plus Pb plus 2 is forming Sn plus 2 plus Pb. So E of cell is equals to E naught of cell minus 0.0591 by 2 into logarithm of concentration of Sn plus 2 divided by concentration of Pb plus 2. This was the Q value reaction quotient for this particular equation. What is E naught of cell? E naught of cell is equals to E naught of Sn is converting into Sn plus 2, Sn to Sn plus 2 plus E naught of Pb plus 2 to Pb, Pb plus 2 to Pb. What is Sn to Sn plus 2 E naught? Sn plus 2 to Sn is given as minus 0.14, Sn to Sn plus 2 is plus 0.14, Pb plus 2 to Pb is minus 0.13, 0.01 is the E naught. So E of cell is equals to 0.01 minus 0.0591 by 2 into logarithm of concentration of Sn plus 2. Sn plus 2 how much? 1 molar divided by concentration of Pb plus 2 is 10 power minus 3 molar. So 0.01 minus 0.0591 by 2. Logarithm of 10 power 3 is 3. So it's 0.01 minus 0.0591 by 2 into 3. This is the value. Check the calculation and report your answer. Is that clear, students? Everything clear or not?
Yes, sir.
Yes.
Yes, right. Let us try to solve more problems. More problems means more clarity. Calculate the equilibrium constant for the reaction. Equilibrium constant K we have to find out. They have given a particular reaction. We know delta G naught is equals to minus NF E naught of cell. Delta G naught is also equal to minus 2.303 RT log K. So 2.303 RT minus 2.303 RT log K is equals to minus NF E naught. Minus minus gets cancels out. So E naught is equals to 2.303 RT by F is 0.0591 divided by N into log K. So let us try to figure out E naught of cell, and then from there you will get log K. What is N? Plus 2 to plus 3 1 electron, plus 4 to plus 3 1 electron. So N is equal to 1. So E naught of cell is equals to E naught of Fe plus 2 to Fe plus 3 plus E naught of Ce plus 4 to Ce plus 3. Fe plus 2 to Fe plus 3, how much? Fe plus 2 to Fe plus 3 plus
Minus
3
0.
to plus, yeah, minus 0.68. Ce plus 4 to plus 3 is 1.44. How much is this value? 1.44
0.76.
0.76. This is E naught. So now write down E naught is 0.76 and they have asked you to take 2.303 RT by F is 0.06. So instead of 0.0591, you have to take 0.06. 0.06 by 1 into log K. 0.06, 0.76. How many times cancels? Log K is equals to 76. 0.76 by 0.06. 72 by 6 is 12. So 0.72 plus 0.04 divided by 6. That is like 12 plus 4 by 3. 12 plus 4 by 6. 12 plus 2 by 3. Try to calculate. It will be something around 12.66. 666, you can write as 67. Yes or no?
Yes,
Log
sir.
K is equals to 12.67 you should get, because I have written 76 as 72 plus 4. Like 0.76 as 0.72 plus 0.004. 0.72 by 0.06 is 12 times. 0.04 by 0.06 is 4 by 6, 2 by 3 times. So log K is equal to 12.67. So what is K? K is equals to 10 power 12.67. Now I can write this K as K is equal to 10 power 12 into 10 power 0.67. And they have given a logarithm of 4.68 is equal to 0.67. From here I can write 4.68 is equal to 10 power 0.67. So I can write K is equals to 4.68 into 10 power 12. K is equal to 4.68 into 10 power 12. That will be your right answer. Because logarithm of 4.68 is given as 0.67. So 4.68 is equals to 10 power 0.67. So K is equal to 4.68 into 10 power 12. That will be your respective right answer. Is that clear, students?
Yes.
Yes.
Yes, right. 0.1 molar copper sulfate solution in which copper electrode is dipped at 25 degrees Celsius. Calculate the electrode potential of copper electrode. E naught of Cu plus 2 to Cu is given as 0.34. Copper electrode we have to find out. So there is some rod. Copper rod has been dipped in 0.1 molar copper sulfate solution in which copper rod is dipped. Calculate the electrode potential. So E of Cu plus 2 to Cu we have to calculate. That is equals to E naught of Cu plus 2 to Cu minus 0.0591 by N. N is 2. What is the reaction? Cu plus 2 electron gives rise to Cu. For this reaction, what is the K? Logarithm of 1 by concentration of Cu plus 2. So that is equal to E naught value 0.34 minus 0.0591 by 2 into logarithm of 1 by, what is the concentration of Cu plus 2? 0.1 10 power minus 1 molar. 0.34 1 by 10 power minus 1 is log 10 is 1. So 0.34 minus 0.0591 by 2. These many volts. You can approximate this to 0.06. 0.06 by 2 is 0.03. 0.34, 0.03 we have removed means approximately 0.31. Slightly greater than that. Right? Look at this reaction. Calculate the EMF of the cell. CR is converting into CR plus 3 is a simple vertical line. CR to CR plus 3, 0.1 molar. Salt bridge Fe plus 2 to Fe. Fe plus 2, 0.01 molar. Given E naught, CR plus 3 to CR, Fe plus 2 to Fe all are given. So E of cell is how much? E of cell is equals to E of oxidation plus E of reduction. E of oxidation plus E of reduction, that is nothing but E of cell. So Cr is converting into Cr plus 3 electron, and Fe plus 2 is taking up 2 electron to form Fe. What was the cell equation? I have to multiply the first equation with 2, second equation with 3. I'll be having a respect to cell equation as 2Cr plus 3Fe plus 2 converting into 2Cr plus 3Fe. So E of cell is equals to what? E of cell is equals to E naught of cell minus 0.0591 by n into logarithm of q. What is n, students? What is n? Either 2 or 3. Because in the oxidation you have 3 electrons lost, in the reduction you have 2 electrons gained. But what is n in this final equation?
6.
6, because this is the equation, right? Cell equation. So 2Cr plus 3Fe plus 2 converting into 2Cr plus 3. So 1 Cr is undergoing 3 units. 2 Cr will be having 6 units. 1 Fe is undergoing 2 units. So 3 Fe will undergo 6 units. So E of cell is equals to E naught of cell minus 0.0591 by 6 into logarithm of Q is concentration of Cr plus 3 whole power 2 divided by concentration of Fe plus 2 whole power 3. What is E naught of cell? E naught of cell is E naught of Cr to Cr plus 3 plus E naught of Fe plus 2 to Fe. Fe plus 2 to Fe. Yes or no? E naught of Cr to Cr plus 3 plus E naught of Fe plus 2 to Fe minus 0.0591 by 6 into logarithm of concentration of Cr plus 3 how much? 0.1, that is 10 power minus 1 whole square, 10 power minus 2. Concentration of Fe plus 2 is 0.01, that is 10 power minus 2 whole power 3 is 10 power minus 6. So now just substitute. Therefore, E of cell is equals to E naught of Cr to Cr plus 3 minus of minus 0.75 plus Fe plus 2 to Fe minus 0.45 minus 0.06, I will take approximately, divided by 6 into logarithm of 10 power 4. 0.75 minus 0.45 is 0.03, 0.3. 0.75 minus 0.45 is 0.3 minus 0.01 into 4. Approximately how much?
26 volt. 0.
0.26 or 296? 26, right? 0.04 you are removing, right? Just approximately, right? Consider the reaction Cl2 gaseous plus 2Br minus aqueous gives rise to 2Cl minus plus Br2 liquid. The EMF of the cell when Cl minus and Br minus concentration is 0.01 and Cl2 gas at 0.25 pressure will be E of cell is equals to what? E naught of cell minus 0.0591 by n is 2 electrons into logarithm of Q. What is Q? Concentration of Cl minus whole square. Br2 is liquid. You have to take active mass of liquids and solids as unity, divided by concentration of Br minus whole square into partial pair of Cl2. Cl2 is a gas. Concentration of Cl minus is equals to concentration of Br minus. So they are going to be 1 molar. They are equal. So they are going to cancel out. They are equal to 0.01 molar. So they are cancelled out. E naught of cell is given as 0.29 minus 0.0591 by 2 into logarithm of 1 by 0.25 is logarithm of 4. So this is your answer, ultimate answer. Log 4 is 2 into log 2. Do the calculation, you will get the answer. Is that clear, students? Is the examples clear or not? Different examples.
Yes.
Yes, sir.
Solving a lot of examples only to get clarity. Okay, you should also solve. How much will the potential of a hydrogen electrode change when its solution initially at pH is equal to 0 is neutralized to pH is equal to 7? pH is equal to 0 means what? pH is equal to 0 means negative logarithm of concentration of H plus is equal to 0. So logarithm of concentration of H plus is equal to 0. Concentration of H plus is equals to 1 molar. 10 power 0, that is 1 molar. So pH is equal to 0 means concentration of H plus is 1 molar. Concentration of H plus is 1 molar means what? It is a standard condition or not? Standard condition.
Yes, sir.
So they have not mentioned whether it is oxidation or reduction. So as per IUPAC, we have to take the reduction reaction. What is the reduction reaction? 2H plus will take up 2 electron, converting into H2 gas. What is E of H plus to H2? E of H plus to H2 is E naught of H plus to H2 minus 0.0591 by 2 into logarithm of partial pair of H2 divided by concentration of H plus whole square. Initially, whenever pH is equal to 0, that is a standard condition. That is nothing but E naught of H plus to H2. So E of H plus to H2 is equals to, with respect to stand only they are asking. Initially we have 0 minus 0.0591 by 2. Partial pressure, did they mention any pressure? They have not mentioned, so we have to take 1 atmosphere. pH is equal to 7 means what? pH is equal to 7 means negative logarithm of concentration of H plus is 7. So concentration of H plus is 10 power minus 7.
Right.
So 1 by concentration of H plus whole square, 10 power minus 7 whole square. So that is equals to minus 0.0591 by 2 into logarithm of 10 power 14. That is nothing but minus 0.0591 by 2 into log 14 is 14. Log 10 power 14 is 14. 14 by 2 is 7. So E of H plus to H2 is minus of 0.0591 into 7. You can approximate this to minus 0.06 into 7. So minus 0.42 you will get. So electrode potential increased or decreased? Decreased by how much quantity? By 0.41. So decreases by 0.41. That is the right answer. Decreases by 0.41. That will be right answer. Right. We do have next problems. I'll just try to give 3 more problems to you as homework. We have some 5 problems. 1, 2, 3, 4, 5. You try to solve these problems. Next class I'll discuss these problems and then proceed with the next concept of concentration cells and then electrolytic cells. Fine. Thank you all everyone. Bye.
Thank you, sir.
Thank you, sir. Thank you, sir. Thank you, sir.